All right, we're ready for this last section in Chapter 8, Section 5. It's the last one that we're going to do in Chapter 8. An angle of elevation is the angle formed when an observer's line of sight is above a horizontal line. So this is a little picture. Oh, I did that. This little guy was looking up at an angle. So this would be the horizontal line. And the angle that he or she is looking is up. And then there's this angle in between that they call the angle of elevation. All right, so here's an example. We have, actually there's two things going on here, but the one we want to talk about is the angle of elevation. So which one of these looks like it's looking up from a horizontal line? This is our horizontal line. Okay, and then this little angle right in here is the angle of elevation. So from this building, it looks like the top of a building, there's an angle up to the helicopter. Horizontal is just the flat. Angle of elevation is going up. And we would say angle TSL, so T to S to L, that's the angle of elevation. Let's try one in a problem then. It says the angle of elevation from point A, which is right here, to the top of a cliff is 34 degrees. So here's the horizontal line, and then the angle up from that horizontal is 34 degrees. If point A is 1,000 feet from the base of the cliff, how high is the cliff? So we're still going to be using the trig ratios when we work on these problems. We have a triangle. We're making it a right triangle so that these will work. It's 1,000 feet on this leg. And then the question is, what about this leg? How high up is the cliff to meet this angle of elevation? So if this is our angle that we're doing, you're using, we look over here, this is an opposite angle or opposite side. And then this would be, it's not the hypotenuse, right? Here's the hypotenuse, the longest side. So this must be adjacent. If we have adjacent and opposite, which trig ratio do we want to use? Hopefully you said tangent. That's right. The tangent of 34 degrees, and then it's opposite over adjacent, x over 1,000. And you might want to write on here somewhere SOHCAHTOA, just to keep those right in the front of your thought process. Okay, we want to solve for x. What's that side of the triangle that we don't know? So x is divided by 1,000. We would multiply by 1,000, and we have to do it to both sides to keep it equal. 1,000 divided by 1,000 is 1. So over here we have 1,000 tangent of 34 equals x. Grab that calculator. 1,000 tangent of 34 is 674.5. Would go with 2 places after the decimal. 674.51 equals x. And then it's a word problem, so we'll have to put some words back in there. 674.5 feet to the top of that cliff. Okay, so it kind of comes together with the trig that we've done. And these are more like a real life problem, something you'd actually see in the world. All right, let's do one more together. Find the angle of elevation of the sun when a 12.5 meter tall telephone pole casts an 18 meter shadow. So let's see. We've got the sun, and here's this tall telephone pole. And as the sun hits it, it casts this shadow down. So this is like the shadow of the phone pole. We know the shadow is 18 meters long. We know that the telephone pole is 12 and a half meters long, but what we don't know is that angle right there. What is that? So we've done these before, missing angle. We'll use this right triangle. We have a leg and a leg, but we don't have the hypotenuse. And this guy would be opposite from the angle that we're talking about. And this side would be adjacent. So we have opposite and adjacent. Which trig function is that? It's tangent again. They're not all going to be tangent. Actually, yeah, they're not all going to be tangent. But this one is, yet again, tangent of, we don't know. So let's put an X there. That's what we're trying to find. What is that angle? The tangent of that angle is opposite over adjacent. And do you remember, this is the one when we don't have the angle measure, then we have to take the inverse. And this actually is what we are taking the inverse of. That will give us the measure of that angle that we don't know. Calculator again, right? So second tangent, make sure you've got that little inverse sign up there. We're taking the inverse. And it was 12.5 divided by 18. Okay, make sure you can get your calculator to say that. 34.78 is the measure of angle X. So we will put 34.78 degrees. All right, one for you to try. Awesome. I'll let you pause the video, try that one, and then come back and we'll check it. All right, let's see. The angle of elevation from point A to the top of a hill is 49 degrees. If point A is 400 feet from the base of the hill, how high is the hill? I like these little pictures that they've given us because it's a little easier to understand the problem sometimes. So we know the angle of elevation. We know that the distance from the hill is 400 feet. What we don't know is the height of the hill. So let's see. This would be adjacent. Opposite is the one we don't know. And looks like tangent again, doesn't it? I really don't want you to think it's tangent every time. Tangent of 49 is opposite, don't know, over adjacent, 400. Okay, he's divided by 400. Let's multiply both sides. So that is just 1. Grab our calculator. 400 times the tangent, 49. 460.15. And we have to throw some words back in there. So we'll say he's 460.2 feet. Yeah, it was in feet. Feet from, or the hill is 460.2 feet up. All right, that is angle of elevation. Now on the other side, we want to look at angle of depression. Not the kind of depression like where you are feeling mentally and emotionally drained. A little bit different. That's the one I always think of. Angle of depression is the angle formed when an observer's line of sight is below a horizontal line. So we're going the other way now. This is the horizontal line up here, and there's this angle below it. That's a depression, an angle of depression. Okay, so let's look at an example. Same picture we had on the front where we did the angle of elevation, but there's also an angle of depression in this same scenario. This is the horizontal line. Horizontal line. And from that helicopter, not looking horizontal, he's looking down, angle of depression. So the angle, this little angle here is our angle of depression. And we would call it angle FLS. Angle FLS. Okay, so elevation goes up, depression goes down. There's always that horizontal that is your like base or the anchor that you're measuring off of when you do an angle of elevation or depression. And one thing you want to remember from last semester when you work on depression problems, angle of depression problems, is that remember that alternate interior angles are congruent. So I know we're scratching back there quite a ways. Alternate, so they're opposite sides of that transversal, and they're also interior, so they're on the inside of those two lines. These two angles are congruent. When you have two parallel lines cut by a transversal, alternate interior angles are congruent. So, and this is transversal. Remember pulling that up? I saw a lot of good pictures in those final projects for the semester with transversals, alternate interior angles. Okay, so that's going to help us a little bit. Let's try this one. This says a ski run is 1,000 yards long with a vertical drop of 208 yards. Vertical is straight up and down, like you're jumping straight up and down. Find the angle of depression from the top of the ski run to the bottom. Okay, so here is the right triangle that we're going to use. The ski run is 1,000 yards long. The vertical drop, if he just went straight down through the mountain to the bottom of his run, it would be 208 yards. We don't know this angle of depression. And what we want to remember with alternate interior is that that angle is congruent to this angle. These are parallel lines cut by a transversal. So we can use this angle of the triangle and it will be congruent to that angle. Okay, another way you could do that is find this angle, and then since this is 90 degrees, you could subtract it. So you actually have alternate ways to look at this, or I'll say various ways to look at this, but we're going to use this guy right here. So we have, this will be our angle. We know opposite is 208. We know the hypotenuse this time is 1,000. And what they're asking is, what's the measure of that angle? So let's call that angle X. And if we have opposite and hypotenuse, we have the sine of, we're going to say X equals opposite over hypotenuse, 208 over 1,000. Okay, and this is one where we don't know the angle, so we've got to do the inverse. We're undoing it. So the sine, the inverse, and then that answer was 208 over 1,000. If we undo it, that will give us our beginning angle, our measure for that angle. So grab our calculator. Inverse 208 divided by 1,000 is 12 point, I'm going to say 0.01 equals the measure of angle X. And then we have to put some words. Actually, for this one, it's not really words. It's a sign or a symbol. Oop, I did that wrong. Because it is degrees. So it's about a 12-degree angle. And actually, if you rounded that to just 12, I think that would be perfectly acceptable rather than 12.01. That's crazy. Okay, got one for you to try. Looks like a little airplane. I'm not sure. Some kind of UFO. Oh, a space. Oh, it's an air traffic control tower. All right, pause your video and try that one. All right, let's try. From the top of a 120-foot high tower, an air traffic controller observes an airplane on the runway at an angle of depression of 19 degrees. So one thing I want you to really think about is, and they put it in the picture for us, but the 19 degrees is the difference from the horizontal. So don't try to plug 19 in as the angle inside the triangle. It's not going to work. 19-degree depression. How far from the base of the tower is the airplane? So we're looking for this leg. We've got this leg, looking for that leg. We don't even care about the hypotenuse. Now remember that this and this, those angles are congruent because that's two parallel lines. They're both horizontal, cut by a transversal. So we're going to work as if this is the angle we're looking for, and we know, or that's the angle we have, 19 degrees. And we have opposite, and we're looking for adjacent. Opposite and adjacent. So that sounds like another tangent, doesn't it? Whew. The tangent of, we do have an angle measure, and then it's opposite over adjacent, 120 over, that's where our x goes. All right, let's do this. Multiply both sides by x. Not there, not there. And then if I have x times the tangent of 19, and I just want x, and I need to divide both sides by the tangent of 19, and we'll have, let's see, 120 divided by the tangent of 19, 348.51. And were those feet? Those are feet. So 348.5 feet from the air traffic control tower to that airplane out on the runway. Okay, that's angles of elevation and angles of depression. You guys have an assignment with a few practice problems. Go ahead and give those a try. We'll talk about them in class. See ya.